So we're starting into chapter 7. We did a little bit with chapter 6, and now we're going to start into chapter 7. So we're in section 7.1. And we're going to talk about surface area and volume. And we've talked a little bit about it already with our linking cubes, but we're going to go into a little more detail today. So the first shape we want to talk about, guys, let's put those away, please. A right rectangular prism. So we're going to talk about the surface area and volume of a right rectangular prism. When we say right rectangular prism, what kind of shape are we talking about? If we wanted to use kind of an everyday, a rectangle, but it's a prism, so what would it look like? A box. A right rectangular prism is just a box. So we're talking about a box shape. And our box has dimensions L, W, and H, length, width, and height. Let me get a picture and we'll label it. So there's our prism. Let me make it a little smaller. There's our right rectangular prism. And our dimensions, we'll call this L, W, and H. It doesn't matter which side we call length, width, and height. But we'll just do it this way just to make it easier. So we want to know the surface area and volume. Surface area. And we usually use a capital S to mean surface area. So surface area equals, what we're doing with this formula is we're just adding up the area of each side. So we have two ends, we have two sides, and two that are a top or a bottom. So we have 2 L times W. That is 2 of these pieces. We have one here and one here, plus 2 times L times H. That's these side pieces. We have 2 of those. And then we have 2 ends. 2 W times H. So all we're doing is adding up the areas of each of the sides of the box. We have two ends, 2 tops, and 2 sides. So we're adding those all together. So if you don't remember the formula, just remember that we can always just add up the areas of all the sides. And the volume. How do we find the volume of a box? What is it? Length times width times height. LWH. Yes. Question? Yeah. All right, and our units for surface area are square units. And our units for volume are cubic units. Sure. So now we have 3 different types of units to keep track of. When we're talking about length, our unit is just units, centimeters, inches, meters, kilometers. When we're talking about area or surface area, our units are square units, square meters, square inches, square kilometers, square miles. And when we're talking about volume, we have cubic units, cubic inches, cubic millimeters, cubic centimeters, cubic miles. So we have to keep track of 3 different kinds of units now: length, area, and volume. So let's look at a quick example of calculating with these formulas. So we have a box with dimensions 6 by 8 by 12 centimeters. And we want the surface area and the volume. So let's plug into our formula, our surface area. It doesn't matter what order I label these: length, width, height. So I'm just going to do it this way just to help me remember. So I'm going to do 2 times 6 times 8 plus 2 times 6 times 12 plus 2 times 8 times 12. So I'm just plugging into my formula. If I calculate these out, 2 times 6 times 8, I get 96. Plus 2 times 6 times 12 is 144. Plus 192. And I add those all together, and I get 432 centimeters squared. And again, all we're doing is finding the area of each side of the box and adding them all together. And our volume is length times width times height, so 6 times 8 times 12, and I get 576 centimeters cubed. So this is something that we're all relatively familiar with. We've all found surface area and volume of boxes before. But this formula is one that we can use. If you remember this formula, you can use it. Otherwise, just remember you're adding up all the sides, adding up the areas of all the sides. Questions on that part? All right, let's talk about cubes. Cubes are a special kind of right rectangular prism because cubes have squares as their bases, and squares are rectangles. So a cube is a special kind of right rectangular prism. So let's draw a picture. And we have a special formula for cubes. Make that look a little better. So what do we know about the sides of a cube? They're all the same. So we're going to call the sides of this cube S for a side. And I try to make this nice and curvy so we know it's an S and not a 5. I think so. So the side length of our cube is S units. So the surface area we use a capital S for surface area. So what's the area of one face of this cube? S squared. And how many faces do we have? 6. So our surface area is going to be 6 S squared. So our formula for a right rectangular prism gets a lot simpler for a cube because the sides are all the same. And the volume. So if we do length times width times height, we get what, Tim? S cubed. So our volume is S cubed, and this is square units. And this is cubic units. So calculating these is pretty easy. The problem that gets a little more tricky, and we need to learn how to use a new key on our calculator, is when we have the volume and we need to figure out the side length. So let's look at an example of that. So let's say we have a cube with volume equal to 100 cubic centimeters. And we want the surface area. Well, in order to calculate our surface area, what do we need to do? What do we need to know? We need to know the side length. So from our volume, we have to figure out our side length, and then we can figure out our surface area. So I'm going to use the volume formula. My volume, 100, equals the side length cubed. How do we undo a cube? How do we undo a square? Square root. So when we have a cube, we have to use the cube root. Now on your calculator, it depends on what kind of calculator you have. But you should have a key that either looks like this on your calculator, and it might be one of the shifted keys, or you should have a key that looks like this, or some kind of variation of those two. And this is the key that you'll need to use to find the cube root. So I'm going to grab a calculator. If you have a Texas Instruments, something like this, this particular one has this button. So what I need to do to find my side length, the side length is the cube root of 100. So in this particular calculator, I'm going to do I have to do 3, and then I press let's see, this calculator has this button. Sorry, this calculator has this one. So I'm going to do 3, and then I press the cube root button, and then I press 100. So when I do that, I get S is about 4.64 centimeters. If you need help finding the cube root button or figuring out how to use it on your calculator, bring your calculator to me later, and I'll show you how to do it. If on a quiz or a test you can't figure out how to use that cube root button on your calculator, bring it up to me and I can show you how to do that. But we will need to be able to find cube roots. So we found our side length, so now we can find our surface area. Our surface area is 6 times 4.64 squared, and when I plug that into my calculator, I get 129.27 centimeters squared. So if we have volume, if we have the volume of the cube, and you'll see these kinds of problems in your homework, if you have the volume of the cube and you want to find the side length, you have to take the cube root of the volume. And that's going to be one of these two kinds of buttons, most likely on your calculator. Questions on that? All right, the last thing we need to talk about today is surface area to volume ratio. And surface area to volume ratio is just all that we're interested in here is, the way we write it is S over V. And all we're doing is dividing the surface area by the volume. So we're just dividing the surface area by the volume. The reason we're interested in this is the surface area to volume ratio tells you some important things about your shape. If your surface area to volume ratio is large, so that means the surface area is big compared to the volume. That means you have a lot of outside and not a lot of inside. So for example, if you were talking about a plant, and your plant has a wide, thin leaf, so like a palm tree or something that has a big, thin leaf. So it has a lot of surface area and not a lot of volume. What that lets that leaf do is absorb a lot of sunlight. It can get a lot of sunlight into the inside of the leaf. So the surface area lets the leaf gather in a lot of sunlight compared to the amount of volume that the leaf has. Now the downside of that is that surface area can also lose a lot of moisture. So a big broadleaf plant is probably not going to grow in a really dry area. If you look at a cactus is kind of round, kind of barrel shaped. So it has a big volume compared to its surface area. So it can hold a lot of water inside, and it doesn't lose as much out of its surface. So the surface area to volume ratio of a cactus would be small because there's not as much surface area compared to the volume. If you were building something, say you were building a container, you would want a small amount of surface area because you don't want to spend as much money to build the container, but you want the volume to be large because you want your container to hold a lot of stuff. So you would want the surface area to volume ratio to be small. You want a very small on the outside, but a big volume. So that's why we're interested in surface area to volume ratio, because it tells you something about the shape, and depending on what you're trying to do, you want different surface area to volume ratios. So let's do one example of calculating a surface area to volume ratio, and then we will be done. So let's say we have a box, and our dimensions for our box are 7 by 3 by 5 inches. And we want the surface area to volume ratio. So we need to calculate the surface area and the volume. I'm just going to call this L, W, and H. Again, it doesn't matter what order you put these in. So let's calculate our surface area first. Surface area is 2 times 7 times 3 plus 2 times 7 times 5 plus 2 times 3 times 5. calculate these out, and we get 42 plus 70 plus 30. And we get 142 inches squared for our surface area. And our volume is just length times width times height. So 7 times 3 times 5. And we get 105 inches cubed. So our surface area to volume ratio, we're just dividing the surface area by the volume. S divided by V is 142 divided by 105. And for our surface area to volume ratio, we're not worried about units. We just want a ratio. And if I plug this into my calculator and calculate it out, we get 1.35. So the surface area to volume ratio of this box would be 1.35. So this tells us that the surface area is 1.35 times bigger than the volume, essentially. It's not exactly that, but that's kind of what this is telling us. So the surface area is a little bit bigger compared to the volume. Any questions on surface area to volume ratio? So there are some problems in your homework that will ask you to try to think about why something might be shaped the way it is, and when those problems, it's asking you to think about the surface area to volume ratio of those things, like the example I gave with a leaf or a container, something like that. All right.